high-speed connectivity, secure data handling, and reliable security systems. These are examples of what were once called impossible in the past, but are now considered the norms of the present. But Monica will take it a step further. Monica provides a vast variety of network services ranging from LAN implementations to security systems as well as after-service technical support. Monica has been extending its services to renowned institutions since 2002, keeping in mind the trend of progress and development of technological advancement.
Introducing Monica's proposal for the Roque Ruano building. Let's start off with our suggested wide area network termination to the engineering building's main router, the Cisco ASR1009X. For this purpose, we specifically used a single-mode optic fiber cable that can extend up to 500 meters without any signal degradation to connect to the internet and also to the other infrastructures of UST.
For the LAN implementation, Monica's proposal involves the use of a fully modular switch, the Cisco Catalyst 4510R. This is connected to the main router with modules that are able to support gigabit per second speeds with power over Ethernet copper cables. The 4510R will also support MT-RJ terminated 10 gigabit interfaces for multi-mode optic fiber cables. Both cables will be encased in metallic cable slots installed inside the walls. The optic fiber cables will serve as the backbone cable for the computer laboratory rooms and will be connected to the room's corresponding switch, the Cisco SG500X. If desired, a single SG500X switch can have 48 computer workstations connected all at once and is scalable up to 192 computers if 4 of these switches are stacked.
Let's move on to access points. The wired access points are provided by Ethernet patch panels at every classroom, and each of these panels is directly connected to the main router with a Category 7A cable terminated by an RJ45 connector. Plugging in these devices to the panels will grant that device an internet connection with a theoretical maximum throughput of 1 gigabit per second. Going into wireless accessibility of our proposal, Monica's recommendation is the Ubiquiti Unify AP-AC Pro. These access points are mindfully placed throughout the building to provide full coverage of internet connectivity inside it. Unify AP-AC Pro is powered by its own physical Ethernet connector cable through Power over Ethernet.
The Dahua CCTV cameras have a resolution of 8.3 megapixels and record at a rate of 30 frames per second. Granted that the dome-type cameras are capable of panning their view, it is optimal for classroom surveillance. The bullet cameras, however, are great for hallway monitoring for their great image sensor and zooming properties. These cameras are powered through Ethernet cables connected to Dahua's proprietary network video recorder that supports the camera's power through PoE. In the event of expanding surveillance systems, Dahua's NVR can support cameras built by third-party manufacturers. Monica's chosen workstation is the Dell XPS 27-inch all-in-one desktop computer. It comes with a 64-bit Windows 10 operating system pre-installed, a 7th generation Intel Core i7-7700 processor, 16GB of DDR4 RAM, and a 512GB SSD for a faster response than a typical hard drive storage. Each classroom also has a 4K Ultra HD TV display for better viewing experience on lecture videos and PowerPoint presentations during class.
We strongly recommend the use of a star topology network. With the main router as its network edge and gateway outside of the network, this router provides the internet connection to all of the smart devices within the engineering building. This router, along with the main switch, is located at the third floor within a server equipment room. These rooms are conditioned to keep the ambient temperature below 20 degrees Celsius and maintain both the main router and switch at its operating temperatures. Transitioning to our structured cable plan, we used a metallic slot for the cables to run through around the building. We used the walls and ceiling as the guide for its layout. The backbone cable is located beside the main stairs that vertically go through from the first floor to the 5th floor. Both the copper and optic fiber cables will go through this backbone structure before reaching their respective rooms and switches from the server equipment room. The optic fiber cables will then be directed towards the computer laboratory rooms wherein they will be connected to the Cisco SG500X switch. The copper cables were used to be able to distribute the wired access points to each possible room.